let's try a new IDE today. It's called Google Anti-Gravity. It's pretty new, a fork of Cursor, I think. It looks like VS Code or Cursor in general, but supposedly it's pretty good with Gemini. And I kind of want to try out because I like Gemini. It's gotten better over the years, or the past couple of years. And I think it might be interesting to see what it's like to use an IDE from Google that's native with Gemini. So I'll just download that real quick. I think it's just a deb file, maybe. Yeah. So I have to do all these things here, and then we should have that ready. So let's just open up Warp. Okay. I was just updating my system here, but it's just running these commands. Okay, so I added the repo in, time to update, and then we'll install anti-gravity, and we'll see how it goes with our pairing it up with our AI studies. At most, we're just probably going to open a bunch of notebooks in there, and I'm not even sure if there's any difference. So, yeah. Okay, so now we've done updating our package repositories. I do see anti-gravity here. So now it's just sudo apt install anti-gravity, and that should kickstart everything. And while I'm doing that, I'll open up the book. I think at this point we're probably on chapter 3. Oh, I don't want to open it up here. I want to open it up with Firefox. Okay. And then we are already in chapter 3, data ethics, are we? Yeah, I think we're on data ethics already. So, okay. That might not even require that much programming. We'll see. I think our usual is like 180, but yeah, automatic zoom, maybe 180. Yeah, 180. Okay. And then we're done here. Gravity. We'll just kick it next to cursor. Welcome. We're going to start fresh. Let's do some dark theme here. Request review for terminal. Request review for review, I guess. Request review for JavaScript. Yeah, review driven development is what we want. Key bindings. Let's do Vim. Extensions. Recommended. What's configured? PHP. Go. Java. I don't need Java. Don't need PHP. Ruby. Don't think I need C#. I do need C++. Maybe Go in the future. Okay. Sign in with Google. Might have to pause this for. Hey, anti-gravity terms of use. I'm not going to allow Google to collect any data, so just proceed. And it looks like we're in. We have Gemini 3 Flash. What else do we have here? What other models? Pro, Sonnet. We also have GPT OSS 120B Medium. Interesting. Okay. Well, that's it. This is the IDE. I can't really resize here, but that's okay. I can at least open up. Oh, I already can see my folders here. Oh, that's interesting. Okay, let's just open up our average dev repo, projects, AI. Are we on Fast AI? I think we're on Fast AI. Yeah. So we could have just clicked on that. Yes, I'll trust the authors. And yeah. Oh, wow, joy. It's already crashed. Don't relaunch. It's probably something in the background. Oh, geez. Okay. That's not a good sign, but okay. Cool. It looks like VS Code or in this case Cursor, so that's all good. Let's just continue reading now. Okay. Data ethics acknowledgement. Dr. Rachel Thomas. This chapter was co-authored by Dr. Rachel Thomas, the co-founder of fastai and founding director of the Center for Applied Data Ethics at the University of San Francisco. It largely follows a subset of the syllabus she developed for the Introduction to Data Ethics course. As we discussed in chapters 1 and 2, sometimes machine learning models can go wrong. They can have bugs. They can be presented with data that they haven't seen before and behave in ways we don't expect. Or they could work exactly as designed, but be used for something that we would much prefer that they were never ever used for. Because deep learning is such a powerful tool and can be used for so many things, it becomes particularly important that we consider the consequences of our choices. The philosophical study of ethics is the study of right and wrong, including how we can define those terms, recognize right and wrong actions, and understand the connection between actions and consequences. The field of data ethics has been around for a long time, and many academics are focused on this field. It is being used to help define policy in many jurisdictions. It is being used in companies big and small to consider how best to ensure good societal outcomes from product development, and it is being used by researchers who want to make sure that the work they are doing is used for good and not for bad. As a deep learning practitioner, therefore, you will likely at some point be put in a situation requiring you to consider data ethics. So what is data ethics? It's a subfield of ethics, so let's start there. Jeremy says, at university, philosophy of ethics was my main thing. It would have been the topic of my thesis if I had finished it, instead of dropping out of school to join the real world. Based on the years I spent studying ethics, I can tell you this. No one really agrees on what right and wrong are, whether they exist or how to spot them, which people are good and which bad, or pretty much anything else. So don't expect too much from the theory. We're going to focus on examples and thought starters here, not theory. In answering the question, what is ethics, the Markula Center for Applied Ethics says the term refers to the following. They are well-founded standards, so ethics are well-founded standards of right and wrong that prescribe what humans should do. Ethics could also mean the study of and development of one's ethical standards. There is no list of right answers. There is no list of do's and don'ts. Ethics is complicated and context dependent. It involves the perspective of many stakeholders. Ethics is a muscle that you have to develop and practice. In this chapter, our goal is to provide some signposts to help you on that journey. Spotting ethical issues is best to do as a part of a collaborative team. This is the only way you can really incorporate different perspectives. Different people's backgrounds will help them see things that they may not be obvious to you. Working with a team is helpful for many muscle building activities, including this one. This chapter is certainly not the only part of the book where we talk about data ethics, but it's good to have a place where we focus on it for a while. To get oriented, it's perhaps easiest to look at a few examples. So we picked out 3 that we think illustrate effectively some of the key topics. Key examples for data ethics. We are going to start with 3 specific examples that illustrate 3 common ethical issues in tech. We'll study these issues in depth later on in this chapter. First, recourse processes. Arkansas's buggy healthcare algorithms left patients stranded. So these are case studies, I guess. Feedback loops. YouTube's recommendation system helped unleash a conspiracy theory boom. Oh, I remember this. Okay, so then bias. When a traditionally African American name is searched for on Google, it displays ads for criminal background checks. In fact, for every concept that we introduce in this chapter, we are going to provide at least one specific example. For each one, think about what you could have done in this situation and what kinds of obstructions there might have been to you getting that done. How would you deal with them? What would you look out for? Bugs and recourse. Buggy algorithm used for healthcare benefits. The Verge investigated software used in over half of the US states to determine how much healthcare people receive, and documented its findings in the article, What Happens When an Algorithm Cuts Your Healthcare. After implementation of the algorithm in Arkansas, hundreds of people, many with severe disabilities, had their healthcare drastically cut. For instance, Tammy Dobbs, a woman with cerebral palsy who needs an aid to help her get out of bed, to go to the bathroom, to get food, and more, had hours of help suddenly reduced by 20 hours a week. She couldn't get any explanation for why her health care was cut. Eventually, a court case revealed that there were mistakes in the software implementation of the algorithm, negatively impacting people with diabetes or cerebral palsy. However, Dobbs and many other people reliant on these healthcare benefits live in fear that their benefits could again be cut suddenly and inexplicably. Feedback loops. YouTube's recommendation system. Feedback loops can occur when your model is controlling the next round of data you get. The data that is returned quickly becomes flawed by the software itself. For instance, YouTube has 1.9 billion users, I'm sure a lot more now, who watch over 1 billion hours of YouTube videos a day. Its recommendation algorithm, built by Google, which was designed to optimize watch time, is responsible for around 70% of the content that is watched. But there was a problem. It led to out-of-control feedback loops, leading the New York Times to run the headline, YouTube unleashed a conspiracy theory boom. Can it be contained? In February 2019, ostensibly recommendation systems are predicting what content people will like, but they also have a lot of power in determining what content people even see. Bias. Professor Latanya Sweeney arrested. Dr. Latanya Sweeney is a professor at Harvard and director of the university's Data Privacy Lab. In the paper, Discrimination in Online Ad Delivery, she describes her discovery that Googling her name resulted in advertisements saying, Latanya Sweeney, arrested? Oh, okay. Those background search things. Even though she is the only known Latanya Sweeney and has never been arrested. However, when she Googled other names such as Kirsten Lindquist, she got more neutral ads, even though Kirsten Lindquist has been arrested 3 times. Oh, that's horrible, unfortunately. Being a computer scientist, she studied this systematically and looked at over 2,000 names. She found a clear pattern. Historically, black names received advertisements suggesting that the person had a criminal record, whereas traditionally white names had more neutral advertisements. This is an example of bias. It can make a big difference to people's lives. For instance, if a job applicant is Googled, it may appear that they have a criminal record when they do not. Why does this matter? One very natural reaction to considering these issues is, so what? What's that got to do with me? I'm a data scientist, not a politician. I'm not one of the senior executives at my company who make decisions about what we do. I'm just trying to build the most predictive model I can. But it does matter. So these are very reasonable questions, but we're going to try to convince you that the answer is that everybody who is training models absolutely needs to consider how their models will be used and consider how to best ensure that they are used as positively as possible. There are things you can do, and if you don't do them, things can go pretty badly. One particularly hideous example of what happens when technologists focus on technology at all costs is the story of IBM in Nazi Germany. In 2001, a Swiss judge ruled that it was not unreasonable to deduce that IBM's technical assistants facilitated the tasks of the Nazis in the commission of their crimes against humanity, acts also involving accountancy and classification by IBM machines and utilized in the concentration camps themselves. IBM, you see, supplied the Nazis with data tabulation products necessary to track the extermination of Jews and other groups in a massive scale. This was driven from the top of the company, with marketing to Hitler and his leadership team. Company president Thomas Watson personally approved the 1939 release of the special IBM alphabetizing machines to help organize the deportation of Polish Jews. Okay, pictured in 3-2 is Adolf Hitler, far left, meeting with IBM CEO Thomas Watson Sr. Wow, shortly before Hitler awarded Watson a Special Service to the Reich Medal in 1937. But this was not an isolated incident. The organization's involvement was extensive. IBM and its subsidiaries provided regular training and maintenance on site at the concentration camps, printing off cards, configuring machines, and repairing them as they broke frequently. IBM set up categorizations on its punch card system for the way that each person was killed, which group they were assigned to, and the logistical information necessary to track them through the vast Holocaust system. See Figure 3.3. IBM's code for Jews in the concentration camps was 8. Some 6 million were killed. Its code for Romanis was 12, which were labeled by the Nazis as asocials, with over 300,000 killed in the Zigeunerlager, or Zigeunerlager, I'm not sure how to pronounce this, or Gypsy camp. General executions were coded as 4, death in the gas chambers as 6. Of course, the project managers and engineers and technicians involved were just living their ordinary lives, caring for their families, going to the church on Sunday, doing their jobs the best they could, following orders. The marketers were just doing what they could to meet their business development goals. As Edwin Black, author of IBM and the Holocaust, observed, to the blind technocrat, the means were more important than the ends. The destruction of the Jewish people became even less important because of the invigorating nature of IBM's technical achievement was only heightened by the fantastical profits to be made at a time when bread lines stretch across the world. Step back for a moment and consider, how would you feel if you discovered that you had been a part of a system that ended up hurting society? Would you be open to finding out? How can you help make sure this doesn't happen? We have described the most extreme situation here, but there are many negative societal consequences linked to AI and machine learning being observed today, some of which we'll describe in this chapter. It's not just a moral burden either. Sometimes technologists pay very directly for their actions. For instance, the first person who was jailed as a result of the Volkswagen scandal in which the car company was revealed to have cheated on its diesel emissions tests was not the manager who oversaw the project or an executive at the helm of the company. It was one of the engineers, James Liang, who just did what he was told. Of course, it's not all bad. If a project you are involved in turns out to make a huge positive impact on even one person, this is going to make you feel pretty great. Okay, so hopefully we have convinced you that you ought to care, but what should you do? As data scientists, we're naturally inclined to focus on making our models better by optimizing some metric or other. But optimizing that metric may not lead to better outcomes. And even if it does help create better outcomes, it almost certainly won't be the only thing that matters. Consider the pipeline of steps that occurs between the development of a model or an algorithm by a researcher or practitioner, and the point at which this work is used to make a decision. This entire pipeline needs to be considered as a whole if we're going to have hope of getting the kinds of outcomes we want. Normally, there is a very long chain from one end to the other. This is especially true if you are a researcher who might not even know if your research will ever get used for anything, or if you're involved in data collection, which is even earlier in the pipeline. But no one is better placed to inform everyone involved in this chain about the capabilities, constraints, and details of your work than you are. Although there's no silver bullet, this can ensure your work is used the right way. By getting involved in the process and asking the right questions, you can at the very least ensure that the right issues are being considered. Sometimes the right response is being asked to do a piece of work is to just say no. Often, however, the response we hear is, If I don't do it, someone else will. But consider this. If you've been picked for the job, you're the best person they found to do it. So if you don't do it, the best person isn't working on that project. If the first 5 people they'll ask all say no to, so much the better. Yes, I guess that's some motivation for us to stand up for the greater good and call out employers if something we feel that we're about to do doesn't feel quite right and could potentially harm society. Yeah, I mean, I know like the job market is pretty bad right now, and I feel very fortunate to have a job. But if I was asked to do something that would actually be unethical, I would definitely not do it. And if it means costing my job, that's something that I would have to probably do in order to like be able to live with myself, knowing that like I fulfilled my job as an engineer and also as an ethical engineer in this case. Okay, it's just me reflecting on that. Okay, so where are we at? Okay, integrating machine learning with product design. Presumably, the reason you're doing this work is that you hope it will be used for something. Otherwise, you're just wasting your time. So let's start with the assumption that your work will end up somewhere. Now, as you are collecting your data and developing your model, you are making lots of decisions. What level of aggregation will you store your data at? What loss function should you use? What validation and training sets should you use? Should you focus on simplicity of implementation, speed of inference, or accuracy of the model? How will your model handle out-of-domain data items? Can it be fine-tuned, or must it be retrained from scratch over time? These are not just algorithm questions, they are data product design questions. But the product managers, executives, judges, journalists, doctors, whoever ends up developing and using the system of which your model is a part, will not be well placed to understand the decisions that you made, let alone change them. For instance, 2 studies found that Amazon's facial recognition software produced inaccurate and racially biased results. Amazon claimed that the researchers should have changed the default parameters without explaining how this would have changed the biased results. Furthermore, it turned out that Amazon was not instructing police departments that use its software to do this either. There was presumably a big distance between the researchers who developed these algorithms and the Amazon documentation staff who wrote the guidelines provided to the police. A lack of tight integration led to serious problems for society at large. The police and Amazon. It turned out that its system erroneously matched 28 members of Congress to criminal mugshots, and the Congress people wrongly matched to criminal mugshots were disproportionately people of color, as seen in Figure 3-4. Oh, that's true. Data scientists need to be part of a cross-disciplinary team. And researchers need to work closely with the kinds of people who will end up using their research. Better still, domain experts themselves could learn enough to be able to train and debug some models themselves. Hopefully, a few of you are reading this book right now. The modern workplace is a very specialized place. Everybody tends to have well-defined jobs to perform, especially in large companies. It can be hard to know all the pieces of this puzzle. Sometimes companies even intentionally obscure the overall project goals being worked on. If they know that employees are not going to like their answers, this is sometimes done by compartmentalizing pieces as much as possible. In other words, we're not saying that any of this is easy. It's hard. It's really hard. We all have to do our best. And we have often seen that the people who do get involved in the higher level context of these projects and attempt to develop cross-disciplinary capabilities and teams become the most important and well-rewarded members of their organizations. It's a kind of work that tends to be highly appreciated by senior executives, even if it's sometimes considered rather uncomfortable by middle management. Topics in data ethics. Data ethics is a big field and we can't cover everything. Instead, we're going to pick a few topics that we think are particularly relevant. The need for recourse and accountability, feedback loops, bias, and disinformation, Let's look at each in turn. Recourse and accountability. In a complex system, it is easy for no one person to feel responsible for outcomes. While this is understandable, it does not lead to good results. In the earlier example of the Arkansas healthcare system, in which a bug led to people with cerebral palsy losing access to needed care, the creator of the algorithm blamed government officials, and government officials blamed those who implemented the software. NYU professor Dana Boyd described this phenomenon. Bureaucracy has often been used to shift or evade responsibility. Today's algorithmic systems are extending bureaucracy. An additional reason why recourse is necessary is that data often contains errors. Mechanisms for audits and error correction are crucial. A database of suspected gang members maintained by California law enforcement officials was found to be full of errors, including 42 babies who had been added to the database when they were less than 1 year old, 28 of whom which were marked as admitting to being gang members. That's impossible, but okay. In this case, there was no process in place for correcting mistakes or removing people after they'd been added. Another example is the U.S. credit report system. A large-scale study of credit reports by the Federal Trade Commission, FTC, in 2012 found that 26 of consumers had at least one mistake in their files, and 5% had errors that could be devastating. Yet, the process of getting such errors corrected is incredibly slow and opaque. When public radio reporter Bobby Allen discovered that he was erroneously listed as having a firearms conviction, it took him more than a dozen phone calls and the handiwork of a county clerk, court clerk, and 6 weeks to solve the problem. And that was only after I contacted the company's communications department as a journalist. So, as machine learning practitioners, we do not always think of it as our responsibility to understand how our algorithms end up being implemented in practice, but we need to. Feedback loops. We explained in Chapter 1 how an algorithm can interact with its environment to create a feedback loop, making predictions that reinforce actions taken in the real world, which lead to predictions even more pronounced in the same direction. As an example, let's again consider YouTube's recommendation system. A couple of years ago, the Google team talked about how they had introduced reinforcement learning, closely related to deep learning, but your loss function represents a result potentially a long time after an action occurs, to improve YouTube's recommendation system. They described how they used an algorithm that made recommendations such that watch time would be optimized. However, human beings tend to be drawn to controversial content. This meant that videos about things like conspiracy theories started to get recommended more and more by the recommendation system. Furthermore, it turns out that the kinds of people who are interested in conspiracy theories are also people who watch a lot of online videos. So they started to get drawn more and more toward YouTube. The increasing number of conspiracy theorists watching videos on YouTube resulted in the algorithm recommending more and more conspiracy theories and other extremist content, which resulted in more extremists watching videos on YouTube and more people watching YouTube developing extremist views, which led to the algorithm recommending more extremist content. The system was spiraling out of control. And this phenomenon was not contained into this particular type of content. In June 2019, the New York Times published an article on YouTube's recommendation system titled "On YouTube's Digital Playground, an Open Gate for Pedophiles." The article started with this chilling story. One of our reviewers for this book, Erlian Garone, led YouTube's video classification team from 2013 to 2016, well before the events discussed here. He pointed out that it's not just feedback loops involving humans that are the problem. There can also be feedback loops without humans. He told us about an example from YouTube. One important signal to classify the main topic of a video is the channel it comes from. For example, a video uploaded to a cooking channel is very likely to be a cooking video. But how do we know what topic the channel is about? Well, in part by looking at the topics of the videos it contains. Do you see the loop? For example, many videos have a description which indicates what camera was used to shoot the video. As a result, some of these videos might get classified as videos about photography. If a channel has such a misclassified video, it might be classified as a photography channel, making it more likely for future videos on this channel to be wrongly classified as photography. This could even lead to runaway virus-like classifications. One way to break this feedback loop is to classify videos with and without the channel signal. Then, when classifying the channels, you can only use the classes obtained without the channel signal. This way, the feedback loop is broken. There are positive examples of people and organizations attempting to combat these problems. Evan Estola, lead machine learning engineer at Meetup, discussed the example of men expressing more interest than women in tech meetups. Taking gender into account could therefore cause Meetup algorithm to recommend fewer tech meetups to a woman. And as a result, fewer women would find out about and attend tech meetups, which could cause the algorithm to suggest even fewer tech meetups to women, and so on in a self-reinforcing feedback loop. So Evan and his team made the ethical decision for the recommendation algorithm to not create such a feedback loop by explicitly not using gender for that part of their model. It is encouraging to see a company not just unthinkably recognize or optimize a metric, but consider its impact. According to Evan, you need to decide which feature not to use in your algorithm. The most optimal algorithm is perhaps not the best one to launch into production. While Meetup chose to avoid such an outcome, Facebook provides an example of allowing a runaway feedback loop to run wild. Like YouTube, it tends to radicalize users interested in one conspiracy theory by introducing them to more. As Renee DeResta, a researcher on proliferation of disinformation, writes, once people join a single conspiracy-minded Facebook group, they are algorithmically routed to a plethora of others. Join an anti-vaccine group, and your suggestions will include anti-GMO, chemtrail watch, flat earther, yes really, and curing cancer naturally groups. Rather than pulling a user out of the rabbit hole, the recommendation engine pushes them further in. It is extremely important to keep in mind that this kind of behavior can happen and to either anticipate a feedback loop or take positive action to break it when you see the first signs of it in your own projects. Another thing to keep in mind is bias, which, as we discussed briefly in the previous chapter, can interact with feedback loops in very troublesome ways. Okay, discussions of bias online tend to get pretty confusing pretty fast. The word bias means so many different things. Statisticians often think when data ethicists are talking about bias, they are talking about the statistical definition of the term bias, but they're not. And they're certainly not talking about the biases that appear in the weights and biases that are parameters of your model. What they're talking about is a social science concept of bias. In A Framework for Understanding Unintended Consequences of Machine Learning, MIT's Harini Suresh and John Gutag describe 6 types of bias in machine learning, summarized in Figure 3.6. Okay, historical bias comes from your data generation, representation bias, measurement bias, I see, okay, aggregation, evaluation, and deployment. We'll discuss 4 of these types of bias, those we found most helpful in our own work, and see the paper for details on the others. Okay, so historical bias. Historical bias comes from the fact that people are biased, processes are biased, and society is biased. Suresh and Kutak says, historical bias is a fundamental structural issue with the first step of the data generation process and can exist even given perfect sampling and feature selection. For instance, here are a few examples of historical race bias in the US from the New York Times article, Racial Bias Even When We Have Good Intentions, by the University of Chicago Sendil Mullainathan. When doctors were shown identical files, they were much less likely to recommend cardiac catheterization, a helpful procedure, to Black patients. Wow. When bargaining for a used car, Black people were offered initial prices $700 higher and received far smaller concessions. Ouch. Responding to apartment rental ads on Craigslist with a Black name elicited fewer responses than with a white name. An all-white jury was 16% points more likely to convict a black defendant than a white one, but when a jury had one black member, it convicted both at the same rate. The Compass algorithm, widely used for sentencing and bailing decisions in the U.S., is an example of an important algorithm that, when tested by ProPublica, showed clear racial bias in practice. Okay, so labeled higher risk but didn't reoffend. African American for 4.9%. Prediction fails differently. I see. Labeled lower risk yet did reoffend. Oh, okay. So a white person who was labeled as lower risk and then they actually did reoffend again, so commit the same crime, I guess. And then labeled higher risk, so black people are labeled higher risk, but they didn't even commit the crime again. Okay. So any data set involving humans can have this kind of bias: medical data, sales data, housing data, political data, and so on. Because underlying bias is so pervasive, bias in data sets is very pervasive. Racial bias even turns up in computer vision, as shown in the example of auto-categorized photos shared by Twitter on Twitter by a Google Photos user, shown in Figure 3-8. Bikes, gorillas? My goodness. All right. Yes, that is showing what you think it is. Google Photos classified a black user's photo with a friend as gorillas. This algorithmic misstep got a lot of attention in the media. We're appalled and genuinely sorry that this happened, a company spokeswoman said. There's still clearly a lot of work with automatic image labeling, and we're looking at how we can prevent these types of mistakes from happening in the future. Unfortunately, fixing problems in machine learning systems when the input data has problems is hard. Google's first attempt didn't inspire confidence, as coverage by The Guardian suggested. Google's solution to accidental algorithmic racism banned gorillas. Google's immediate action over AI labeling of black people as gorillas was simply to block the word, along with chimpanzee and monkey. That's not the solution. These kinds of problems are certainly not limited to Google. MIT researchers studied the most popular online computer vision APIs to see how accurate they were. But they didn't just calculate a single accuracy number. Instead, they looked at the accuracy across 4 groups, as illustrated in Figure 3-10. Microsoft gender classifier, darker male, darker female. I don't get this. Oh, like the difference between a darker male and a dark female? Like, how is it good at classifying it? I see. Okay. IBM system, for instance. Okay, IBM system. Oh, I see. And then the lighter ones have a better percentage of getting it right. IBM system, for instance, had a 34.7% error rate for darker females versus 0.3% for lighter males, over 100 times more errors. Some people incorrectly reacted to these experiments by claiming that the difference was simply because darker skin is harder for computers to recognize. However, what happened was that after the negative publicity that this result created, all of the companies in question dramatically improved their models for darker skin, such that 1 year later they were nearly as good as for lighter skin. So what this showed is that developers failed to utilize datasets containing enough darker faces or test their product with darker faces. One of the MIT researchers, Joy Buolamwini, warned, we have entered the age of automation, overconfident yet underprepared. If we fail to make ethical and inclusive artificial intelligence, we risk losing gains made in civil rights and gender equity under the guise of machine neutrality. Part of the issue appears to be a systematic imbalance in the makeup of popular datasets used for training models. The abstract of the paper, No Classification Without Representation, Assessing Geodiversity Issues in Open Datasets for the Developing World by Shreya Shankar et al. States, we analyzed 2 large publicly available image datasets to assess geodiversity and find that these datasets appear to exhibit an observable Amerocentric and Eurocentric race representation bias. Further, we analyze classifiers trained on these datasets to assess the impact of these training distributions and find strong differences in the relative performance on images from different locales. Figure 311 shows one of the charts from the paper showing the geographic makeup of what were at the time and still are as this book is being written the two most important image datasets for training models. ImageNet and OpenImages. Okay. Wow, so both datasets have mostly US and Europe origins. Okay. So the vast majority of the images from the US and other Western countries, leading to models trained on ImageNet performing worse on scenes from other countries and cultures. For instance, research found that such models are worse at identifying household items such as soap, spices, sofas, or beds from lower income countries. Figure 312 shows an image from the paper, Does Object Recognition Work for Everyone by Terence DeVry et al. Of Facebook AI research that illustrates this point. Oh, I see. Ground truth is soap. Nepal? $288 a month. Oh, Azure said food, cheese bread, cake sandwich. Oh, I see. This was mistaken for food even though it's soap. Okay. Ground truth soap because it's packaged like this. I see. Ground truth spices. Even okay, so then they're all bottle beer, container products, condiments. I see. Condiment sauce, flavor, catsup. Oh wow. Okay, ground truth spices, and they got all of them here. Okay. In this example, we can see that the lower income soap example is a very long way from being accurate, with every commercial image recognition service predicting food as the most likely answer. As we will discuss shortly, in addition, the vast majority of AI researchers and developers are young white men. Most projects that we have seen do most user testing using friends and families of the immediate product development group. Given this, the kinds of problems we just discussed should not be surprising. Similar historical bias is found in the text used as data for natural language processing models. This crops up in downstream machine learning tasks in many ways. For instance, it was widely reported that until last year, Google Translate showed systematic bias in how it translated the Turkish gender-neutral pronoun o into English when applied to jobs that are often associated with males. It used he, and when applied to jobs that are often associated with females, it used she. Oh, but it's gender neutral. It should have been they. We also see this kind of bias in online advertisements. For instance, a study in 2019 by Muhammad Ali et al. Found that even when the person placing the ad does not intentionally discriminate, Facebook will show ads to a very different audience based on race and gender. Housing ads with the same text but picturing either a white or black family were shown to racially different audiences. I see. Measurement bias does machine learning automate moral hazard and error? In American Economic Review, Sendel Mullainathan and Ziad Obermeyer looked at a model that tries to answer the question using historical electronic health record data: what factors are most predictive of stroke? These are the top predictors from the model: prior stroke, okay, cardiovascular disease, accidental injury, benign breast lump, colonoscopy, and sinusitis. Okay. However, only the top two have anything to do with the stroke. Based on what we studied so far, you can probably guess why. We haven't really measured stroke, which occurs when a region of the brain is denied oxygen due to an interruption in the blood supply. What we've measured is who had symptoms, went to a doctor, got the appropriate test, and received a diagnosis of stroke. Actually, having a stroke is not the only thing correlated with this complete list. It's also correlated with being the kind of person who goes to the doctor, which is influenced by who has access to healthcare, can afford their copay, doesn't experience racial or gender-based medical discrimination, and more. If you are likely to go to the doctor for an accidental injury, you are likely to also go to the doctor when you are having a stroke. This is an example of measurement bias. It occurs when our models make mistakes because we are measuring the wrong thing or measuring it the wrong way or incorporating that measurement into the model inappropriately. Okay. Aggregation bias. Aggregation bias occurs when models do not aggregate data in a way that incorporates all of the appropriate factors or when a model does not include the necessary interaction terms, nonlinearities, or so forth. This can particularly occur in medical settings. For instance, the way diabetes is treated is often based on simple univariate statistics and studies involving small groups of heterogeneous people. Analysis of results is often done in a way that does not take into account different ethnicities or genders. However, it turns out that diabetes patients have different complications across ethnicities, and HbA1c levels, widely used to diagnose and monitor diabetes, differ in complex ways across ethnicities and genders. This can result in people being misdiagnosed or incorrectly treated because medical decisions are based on a model that does not include these very important variables and interactions. Representation bias. The abstract of the paper Bias in Bios, a case study of semantic representation in bias in a high-stakes setting by Maria de Arteaga et al. Notes that there is gender imbalance in occupations. Females are more likely to be nurses and males are more likely to be pastors, and says that differences in true positive rates between genders are correlated with existing gender imbalances in occupations, which may compound these imbalances. In other words, the researchers noticed that models predicting occupation did not only reflect the actual gender imbalance in the underlying population, but amplified it. This type of representation bias is quite common, particularly for simple models. When there is a clear, easy to see underlying relationship, a simple model will often assume that this relationship holds all the time. As figure 3-14 from or 3-14 from the paper shows, for occupations that have had a higher percentage of females, the model tended to overestimate the prevalence of that occupation. I see. Okay. For example, in the training data set, 14.6 of surgeons were women, yet in the model predictions, only 11.6 of the true positives were women. The model is thus amplifying the bias existing in the training set. Now that we've seen that those biases exist, what can we do to mitigate them? Addressing different types of bias. Different types of bias requires different approaches for mitigation. While gathering a more diverse dataset can address representation bias, this would not help with historical bias or measurement bias. All datasets contain bias. There is no such thing as a completely de-biased dataset. Many researchers in the field have been converging on a set of proposals to enable better documentation of the decisions, context, and specifics about how and why a particular dataset was created, what scenarios it is appropriate to use in, and what the limitations are. This way, those using a particular dataset will not be caught off guard by its biases and limitations. We often hear the question, humans are biased, so does algorithmic bias even matter? This comes up so often, there must be some reasoning that makes sense to the people who ask it, but it doesn't seem very logically sound to us. Independently of whether this is logically sound, it's important to realize that algorithms, particularly machine learning algorithms, and people are different. Consider these points about machine learning algorithms. Machine learning can create feedback loops. Small amounts of bias can rapidly increase exponentially because of feedback loops. Machine learning can amplify bias. Human bias can lead to larger amounts of machine learning bias. Algorithms and humans are used differently. Human decision makers and algorithmic decision makers are not used in plug-and-play interchangeable way in practice. These examples are given in the list on the next page. Technology is power, and with that comes responsibility. As the Arkansas healthcare example showed, machine learning is often implemented in practice not because it leads to better outcomes, but because it is cheaper and more efficient. Kathy O'Neill, in her book Weapons of Math Destruction, described a pattern in which the privileged are processed by people, whereas the poor are processed by algorithms. This is just one of the number of ways that algorithms are used differently than human decision makers. Others include the following. People are more likely to assume algorithms are objective and error-free, even if they're given the option of a human override. Algorithms are more likely to be implemented with no appeals in place. Algorithms are often used at scale. Algorithmic systems are cheap. So even in the absence of bias, algorithms and deep learning, especially since it is such an effective and scalable algorithm, can lead to negative societal problems such as when used for disinformation. Disinformation has a history of stretching back hundreds or even thousands of years. It's not necessarily about getting someone to believe in something false, but rather often used to sow disharmony and uncertainty, and to get people to give up on seeking the truth. Receiving conflicting accounts can lead people to assume that they can never know whom or what to trust. Some people think disinformation is primarily about false information or fake news, but in reality, disinformation can often contain seeds of truth or half-truths taken out of context. Vladislav Vitman was an intelligence officer in the USSR who later defected to the US and wrote some books in the 1970s and 80s on the role of disinformation in Soviet propaganda operations. In the KGB and Soviet disinformation, he wrote, "Many campaigns are a carefully designed mixture of facts, half-truths, exaggerations, and deliberate lies." In the US, this has hit close to home in recent years, with the FBI detailing a massive disinformation campaign linked to Russia in the 2016 election. Understanding the disinformation that was used in this campaign is very educational. For instance, the FBI found that the Russian disinformation campaign often organized two separate fake grassroots protests, one for each side of an issue, and got them to protest at the same time. The Houston Chronicle reported on one of these odd events. A group that called itself the Heart of Texas had organized it on social media. A protest, they said, against the Islamization of Texas. On one side of Travis Street, I found about 10 protesters. On the other side, I found about 50 counter-protesters. But I couldn't find the rally organizers. No Heart of Texas. I thought that was odd and mentioned it in the article. What kind of group is a no-show at its own event? Now I know why. Apparently the rally's organizers were in St. Petersburg, Russia at the time. Heart of Texas is one of the internet troll groups cited in Special Prosecutor Robert Mueller's recent indictment of Russians attempting to tamper with the U.S. presidential election. Hi everybody. I started reading some of the Fast AI book on chapter 3 about data ethics, and as I was reading the book, I started having something telling me that maybe I shouldn't really post it, and because it has a lot of opinionated things. I do agree with those opinions actually, but I just don't feel comfortable posting that online, because I noticed that as I was watching some of the recording, I did notice myself making some of the same comments as the material in the book, and I kind of don't think that's the right video for this channel. And so I'm going to keep reading, and maybe there's stuff that I could post related to reading just to say that we've read it. The lesson here is that well, not lesson, but the realization here is that I kind of understand why there's a lot of AI videos on YouTube that don't really, like, they deliberately not touch on the data ethics topic very easily, I guess. It has to be some formal presentation usually, but never something casual like these types of videos. And I kind of understand now. And I know I'm rambling and I don't really make sense, but let's just say that you're not going to see this type of video anytime soon. And to make up for it, I'm going to try and chop up the video as much as I can to only contain the non-opinionated things. And so to entertain everyone, I'll just insert more anti-gravity things. And one of the things that we need to do here is we need to configure our fonts and our tab complete, because I think right now this thing probably tries to autocomplete everything, which I really dislike in any code editor nowadays. So maybe one place to look at is the editor settings. For sure, we need to increase the font size a little so that it can be seen during my recordings. Font itself, huge fan of the Mona Lisa variable font. I also want to enable ligatures. Okay, and then you can kind of see that there is already some autocomplete going on. But before I do that, I want to turn off the minimap, and I also want to wrap tabs at least. And word wrap, I do want to turn on word wrap of some sort. Okay, so these are the basic settings that make me happy already. And the one other setting that I want to turn off is that tab complete. I think it's obnoxious. So let's go to anti-gravity settings. I'm pretty sure it's in tab here, suggestions in editor. We can just turn that off. And I think that's it. Really, that's all that I would be annoyed about. Now let's just check in our code. We haven't ever done that. Well, we have, but with just our our Pokemon one, which I think right here, the Pokemon classify one. So let's check in our chapter 1, chapter 2. It's kind of weird. I don't know why there's like a tick here for some reason. Maybe that's odd. It shouldn't be like that. I wonder if it's also in here too. Let's see. Fastai. Huh, that's weird. Why are there ticks in there? I never did that. Let's see. Leading or trailing white space detected in folder name. Can we just change that to chapter 02 like this? Okay, that's fixed. How odd. Okay, same. Maybe when we migrated, it changed everything. Okay, well, that works now. So let's just commit everything. I just call it fastai notes. Well, before we commit, is this worth committing? Oh, this is like oh, this is the stuff that, okay. Some of it is the fastai stuff, some of it is our stuff. Whatever, let's just push. Okay. So we have our editor set up. Now we can just go back to reading and see what I can salvage from this. Okay. I think this is where we stopped at. Okay. Disinformation often involves coordinated campaigns of inauthentic behavior. For instance, fraudulent accounts may try to make it seem like many people hold a particular viewpoint. While most of us like to think of ourselves as independent-minded, in reality we evolved to be influenced by others in our in-group and in opposition to those in our out-group. Online discussions can influence our viewpoints or alter the range of what we consider acceptable viewpoints. Humans are social animals, and as social animals, we are extremely influenced by the people around us. Increasingly, radicalization occurs in online environments, so influence is coming from people in the virtual space of online forums and social networks. Disinformation through auto-generated text is a particularly significant issue due to the greatly increased capability provided by deep learning. We discussed this issue in depth when we delve into creating language models in Chapter 10. One proposed approach is to develop some form of digital signature to implement it in a seamless way and to create norms that we should trust only content that has been verified. The head of the Allen Institute on AI, Oren Etzioni, wrote such a proposal in an article titled How Will We Prevent AI-Based Forgery? AI is poised to make high-fidelity forgery inexpensive and automated, leading to potentially disastrous consequences for democracy, security, and society. The specter of AI forgery means that we need to act to make digital signatures de rigueur as a means of authentication of digital content. While we can't hope to discuss all the ethical issues that deep learning and algorithms more generally bring up, hopefully this brief introduction has been a useful starting point you can build on. We'll now move on to the questions of how to identify ethical issues and what to do about them. Identifying and addressing ethical issues. Mistakes happen. Finding out about them and dealing with them needs to be part of the design of any system that includes machine learning, and many other systems too. The issues raised within data ethics are often complex and interdisciplinary, but it is crucial that we work to address them. So what can we do? This is a big topic, but here are a few steps toward addressing ethical issues. First, analyze a project you are working on. Implement processes at your company to find and address ethical risks. Support good policy and increase diversity. Let's walk through each step, starting with analyzing a project you are working on. Analyzing a project you are working on. It's easy to miss important issues when considering ethical implications of your work. One thing that helps enormously is simply asking the right questions. Rachel Thomas recommends considering the following questions throughout the development of a data project. Should we even be doing this? What bias is in the data? Can the code and data be audited? What are the error rates for different subgroups? What is the accuracy of a simple rule-based alternative? What processes are in place to handle appeals or mistakes? How diverse is the team that built it? These questions may be able to help you identify outstanding issues and possible alternatives that are easier to understand and control. In addition to asking the right questions, it's also important to consider practices and processes to implement. One thing to consider at this stage is what data you are collecting and storing. Data often ends up being used for different purposes than the original intent. For instance, IBM began selling to Nazi Germany well before the Holocaust, including helping with Germany's 1933 census conducted by Adolf Hitler, which was effective at identifying far more Jewish people than had previously been recognized in Germany. Similarly, U.S. census data was used to round up Japanese Americans who were U.S. citizens for internment during World War II. It is important to recognize how data and images collected can be weaponized later. Columbia professor Tim Wu wrote, "You must assume that any personal data that Facebook or Android keeps are data that governments around the world will try to get or that thieves will try to steal." Processes to implement. The Markula Center has released an ethical toolkit for engineering, design, and practice that includes concrete practices to implement at your company, including regularly scheduled sweeps to proactively search for ethical risks in a manner similar to cybersecurity penetration testing. Expanding the ethical circle to include the perspectives of a variety of stakeholders and considering the terrible people. How could bad actors abuse, steal, misinterpret, hack, destroy, or weaponize what you are building? Even if you don't have a diverse team, you can still try to proactively include the perspectives of a wider group, considering questions such as these, provided by the Markula Center. Whose interests, desires, skills, experiences, and values have we simply assumed rather than actually consulted? Who are all the stakeholders who will be directly affected by our product? How have their interests have been protected? How do we know what their interests really are? Have we asked? Who or which groups and individuals will be indirectly affected in significant ways? Who might use this product that we didn't expect to use it, or for purposes we didn't initially intend? Ethical lenses. Another useful resource from the Markkula Center is its conceptual frameworks in technology and engineering practice. This considers how different foundational ethical lenses can help identify concrete issues and lay out the following approaches and key questions. The rights approach. Which option best respects the rights of all who have a stake? The justice approach. Which option treats people equally or proportionally? The utilitarian approach. Which option will produce the most good and do the least harm? The common good approach. Which option best serves the community as a whole, not just some members? The virtue approach. Which option leads me to act as the sort of person I want to be? Markkula's recommendations include a deeper dive into each of these perspectives, including looking at a project through the lens of its consequences. Who will be directly affected by this project? Who will be indirectly affected? Will the effects in aggregate likely create more good than harm? And what types of good and harm? Are we thinking about all the relevant types of harm or benefit, psychological, political, environmental, moral, cognitive, emotional, institutional, or cultural? How might future generations be affected by this project? Do the risks of harm from this project fall disproportionately on the least powerful in society? Will the benefits go disproportionately to the well-off? Have we adequately considered dual use and unintended downstream effects? The alternative lens to this is the deontological perspective. Okay, what does that mean? Let's look it up. Come on. All right. Let's go to ChatGPT. All right. Define deontological. So, relating to deontology, an ethical view where what matters most is whether an action follows a duty, rule, or moral principle. So, where what matters most, though, the most important thing is whether an action follows some sort of duty, rule, or moral principle, not whether it produces the best outcome. So, is the process the most ethical, the best way? Not exactly the result is the most ethical, but the process in getting to there. So deontological ethics: do the right thing because it's right, even if results are worse. Okay, classic example: don't lie is a duty. So lying is wrong, even if it would help someone. Okay, so you should not lie, even if you feel like that is something that could help someone, because that's not deontological in terms of ethics, right? So sometimes it's better to tell the truth, and then even though it will affect someone's like performance, or the outcome of the result is not the most ideal. So that's like outcome-based ethics is consequentialism. Okay, virtue ethics, character-based. I agree. Yes, this makes sense. All right. Now, so that's basic concepts of right and wrong. So, questions to ask is basically, what rights of others and duties to others must we respect? How might the dignity and autonomy of each stakeholder be impacted by this project? And what considerations of trust and of justice are relevant to this design and project? Does this project involve any conflicting moral duties to others or conflicting stakeholder rights? How can we prioritize these? So one of the best ways to help come up with complete and thoughtful answers is to question or to ask questions like these. and to ensure that the people asking questions are diverse. So diverse, meaning diverse viewpoints and diverse in terms of diverse cultures. And also and diversity probably in terms of economics, right? So socioeconomics is something to consider, like where you're from, what area you live in, uh, even like down to what your parents do, right? If you're still in school, it matters most because what your parents do influence how much purchasing power you have, which also influences some of the decisions that you will make, and or even like what you are capable of making. Anyway, the power of diversity. Currently, less than 12% of AI researchers are women, according to a study from Element AI. The statistics are similarly dire when it comes to race and age. When everybody on a team has similar backgrounds, they are likely to have similar blind spots around ethical risks. The Harvard Business Review, HBR, has published a number of studies showing many benefits of diverse teams, including the following: how diversity can drive innovation, team solves problems faster when they're more cognitively diverse, why diverse teams are smarter, and defend your research, what makes a team smarter, more women. Diversity can lead to problems being identified earlier and a wider range of solutions being considered. For instance, Tracy Cho was an early engineer at Quora. She wrote of her experiences describing how she advocated internally for adding a feature that would allow trolls and other bad actors to be blocked. Cho recounts, I was eager to work on that feature because I personally felt antagonized and abused on the site. Gender isn't an unlikely reason as to why. But if I hadn't had that personal perspective, it's possible that that the Quora team wouldn't have prioritized building a block button so early in its existence. Harassment often drives people from marginalized groups off online platforms, so this functionality has been important for maintaining the health of Quora's community. A crucial aspect to understand is that women leave the tech industry at over twice the rate that men do. According to the Harvard Business Review, 41% of women working in tech leave, compared to 17% of men. An analysis of over 200 books, white papers, and articles found that the reason that they leave is that they're treated unfairly, underpaid, less likely to be fast-tracked than their male colleagues, and unable to advance. Studies have confirmed a number of the factors that make it harder for women to advance in the workplace. Women receive more vague feedback and personality criticism in performance evaluations, whereas men receive actionable advice tied to business outcomes, which is more useful. Women frequently experience being excluded from the more creative and innovative roles and not receiving high visibility stretch assignments that are helpful in getting promoted. One study found that men's voices are perceived as more persuasive, fact-based, and logical than women's voices, even when reading identical scripts. Receiving mentorship has been statistically shown to help men advance, but not women. The reason behind this is that when women receive mentorship, it's advice on how they should change and gain more self-knowledge. When men receive mentorship, it's public endorsement of their authority. Guess which is more useful in getting promoted? As long as qualified women keep dropping out of tech, teaching more girls to code will not solve the diversity issues plaguing the field. Diversity initiatives often end up focusing primarily on white women, even though women of color may face additional barriers. In interviews with 60 women of color who work in STEM research, 100% had experienced discrimination. The hiring process is particularly broken in tech. One study indicative of the dysfunction comes from TripleByte, a company that helps place software engineers in companies, conducting a standardized technical interview as part of this process. The company has a fascinating data set, the results of how over 300 engineers did on their exam, coupled with the results of how those engineers did during the interview process for a variety of companies. The number one finding from TripleByte's research is that the types of programmers that each company looks for often have little to do with what the company needs or does. Rather, they reflect company culture and the backgrounds of the founders. This is a challenge for those trying to break into the world of deep learning, since most companies' deep learning groups today were founded by academics. These groups tend to look for people like them, that is, people who can solve complex math problems and understand dense jargon. They don't always know how to spot people who are actually good at solving real problems using deep learning. This leaves a big opportunity for companies that are ready to look beyond status and pedigree and focus on results. Fairness, accountability, and transparency. The Professional Society for Computer Scientists, the ACM, runs a data ethics conference called the Conference on Fairness, Accountability, and Transparency, ACM FACT, which used to go under the acronym FACT, but now uses the less objectionable FACT. Microsoft also has a group focused on fairness, accountability, and transparency, and ethics in AI, FATE. In this section, we'll use the acronym FACT to refer to the concepts of fairness, accountability, and transparency. FACT is a lens some people have used for considering ethical issues. One helpful resource for this is the free online book Fairness and Machine Learning: Limitations and Opportunities by Solon Barocas et al., which gives a perspective on machine learning that treats fairness as a central concern rather than an afterthought. It also warns, however, that it is intentionally narrow in scope. A narrow framing of machine learning ethics might be tempting to technologists and businesses as a way to focus on technical interventions while sidestepping deeper questions about power and accountability. We caution against this temptation. Rather than provide an overview of the FACT approach to ethics, which is better done in books such as that one, our focus here will be on the limitations of this kind of narrow framing. One great way to consider whether an ethical lens is complete is to try and come up with an example in which the lens of and our own ethical intuitions give diverging results. Oskis et al. Explored this in a graphic way in their paper, A Mulching Proposal, analyzing and improving an algorithmic system for turning the elderly into high-nutrient slurry. What is that? Okay, the paper's abstract says that. Okay, what? That didn't even make sense. Okay, let's read this. Okay. The ethical implications of algorithmic systems have been much discussed in both HCI and the broader community of those interested in technology, design, development, and policy. In this paper, we explore the application of one prominent ethical framework, fairness, accountability, and transparency, to a proposed algorithm that resolves various societal issues around food security and population aging. Using various standardized forms of algorithmic audit and evaluation, we drastically increased the algorithm's adherence to the FACT framework, which is FACT, resulting in a more ethical and beneficent system. We discuss how this might serve as a guide to other researchers or practitioners looking to ensure better ethical outcomes from algorithmic systems in their line of work. In this paper, the rather controversial proposal, turning the elderly into high-nutrient slurry, and the results drastically increase the algorithm's adherence to the FACT framework, resulting in a more ethical and beneficent system, are at odds, to say the least. Yes, that's why it didn't make sense to me. In philosophy, and especially philosophy of ethics, this is one of the most effective tools. First, come up with a process, definition, a set of questions, etc., which is designed to resolve a problem. Then try to come up with an example in which that apparent solution results in a proposal that no one would consider acceptable. This can then lead to a further refinement of the solution. So far, we've focused on things that you and your organization can do, but sometimes individual organizational action is not enough. Sometimes governments also need to consider policy implications. Let me read that again. Sometimes governments also need to consider policy implications. Role of policy. We often talk to people who are eager for technical or design fixes to be a full solution to the kinds of problems that we've been discussing. For instance, a technical approach to debias data or design guidelines for making technology less addictive. While such measures can be useful, they will not be sufficient to address the underlying problems that have led to our current state. For example, as long as it is profitable to create addictive technology, companies will continue to do so, regardless of whether this has the side effect of promoting conspiracy theories or polluting our information ecosystem. While individual designers may try to tweak product designs, we will not see substantial changes until the underlying profit incentives change. That's true. Effectiveness of regulation. To look at what can cause companies to take concrete action, consider the following two examples of how Facebook has behaved. In 2018, a UN investigation found that Facebook had played a determining role in the ongoing genocide of the Rohingya, an ethnic minority in Myanmar described by the UN Secretary General Antonio Guterres as one of, if not the most discriminated people in the world. Local activists had been warning Facebook executives that their platform was being used to spread hate speech and incite violence since as early as 2013. In 2015, they were warned that Facebook could play the same role in Myanmar that the radio broadcast played during the Rwandan genocide, where 1 million people were killed. Yet by the end of 2015, Facebook employed only 4 contractors who spoke Burmese. As one person close to the matter said, "That's not 2020 hindsight. The scale of this problem was significant and it was already apparent." Zuckerberg promised during the congressional hearings to hire dozens to address the genocide in Myanmar. In 2018, years after the genocide had begun, including the destruction by fire of at least 288 villages in northern Rakhine State after August 2017. This stands in stark contrast to Facebook quickly hiring 1,200 people in Germany to try to avoid expensive penalties of up to 50 million euros under a new German law against hate speech. Clearly, in this case, Facebook was more reactive to the threat of a financial penalty than to the systematic destruction of an ethnic minority. In an article on privacy issues, how do I pronounce this? Let's ask how to pronounce. Maciej Seglovsky. Maciej Seglovsky. Okay? Seglovsky. What? Maciej. Let's just say Maciej. Okay, Maciej. Maciej. All right, Maciej. Maciej Seglovsky. Okay. In an article on privacy issues, Maciej Seglovsky draws parallels with the environmental movement. This regulatory project has been so successful in the first world that we risk forgetting what life was like before it. Choking smog of the kind that today kills thousands in Jakarta and Delhi, once emblematic of London. The Cuyahoga River in Ohio used to reliably catch fire. In a particularly horrific example of unforeseen consequences, tetraethyl lead added to gasoline raised violent crime rates worldwide for 50 years. None of these harms could have been fixed by telling people to vote with their wallet or carefully review the environmental policies of every company that gave their business to or to stop using the technologies in question. It took coordinated and sometimes highly technical regulation across jurisdictional boundaries to fix them. In some cases, like the ban on commercial refrigerants that depleted the ozone layer, that regulation required a worldwide consensus. We're at the point where we need similar shift in perspective in our privacy law. Rights and policy. Clean air and clean drinking water are public goods that are nearly impossible to protect through individual market decisions, but rather require coordinated regulatory action. Similarly, many of the harms resulting from unintended consequences of misuses of technology involve public goods, such as polluted information environment or deteriorated ambient privacy. Too often, privacy is framed as an individual right, yet there are societal impacts to widespread surveillance, which would still be the case even if it was possible for a few individuals to opt out. Many of the issues that we are seeing in tech are human rights issues, such as when a biased algorithm recommends that black defendants have longer prison sentences, when particular job ads are shown only to young people, or when police use facial recognition to identify protesters. The appropriate venue to address human rights issues is typically through the law. We need both regulatory and legal changes and the ethical behavior of individuals. Individual behavior can't change or can't address. Individual behavior change can't address misaligned profit incentives, externalities where corporations reap large profits while offloading their costs and harms to the broader society, or systemic failures. However, the law will never cover all edge cases, and it is important that individual software developers and data scientists are equipped to make ethical decisions in practice. Cars, a historical precedent. The problems we are facing are complex, and there are no simple solutions. This can be discouraging, but we find hope in considering other large challenges that people have tackled throughout history. One example is the movement to increase car safety, covered as a case study in Datasheets for Datasets by Timnit Gebru et al. And in the design podcast 99% Invisible. Early cars had no seatbelts, metal knobs on a dashboard that could lodge in people's skulls during a crash, regular plate glass windows that shattered in dangerous ways, and non-collapsible steering columns that impaled drivers. However, car companies were resistant to even discussing safety as something they could help address, and the widespread belief was that cars are just the way that they are, and that it was the people using them who caused the problems. It took consumer safety activists and advocates decades of work to change the national conversation to consider that perhaps car companies had some responsibility that should be addressed through regulation. When the collapsible steering column was invented, it was not implemented for several years as there was no financial incentive to do so. Major car company General Motors hired private detectives to try to dig up dirt on consumer safety advocate Ralph Nader. The requirement of seatbelts, crash test dummies, and collapsible steering columns were major victories. It was only in 2011 that car companies were required to start using crash test dummies that would represent the average woman, and not just the average men's bodies. Prior to this, women were 40% more likely to be injured in a car crash of the same impact compared to a man. This is a vivid example of the ways in what biased policy and technology have important consequences. In conclusion, coming from a background of working with binary logic, the lack of clear answers in ethics can be frustrating at first. Yet, the implications of how our work impacts the world, including unintended consequences and the work becoming weaponized by bad actors, are some of the most important questions we can and should consider. Even though there aren't any easy answers, there are definite pitfalls to avoid and practices to follow to move forward toward more ethical behavior. Many people, including us, are looking for more satisfying, solid answers about how to address harmful impacts of technology. However, given the complex, far-reaching, and interdisciplinary nature of the problems we are facing, there are no simple solutions. Julia Angwin, former senior reporter at ProPublica, who focuses on issues of algorithmic bias and surveillance, and one of the 2016 investigators of the Compass recidivism algorithm that helped spark the field of fact, said in a 2019 interview, I strongly believe that in order to solve a problem, you had to diagnose it, and that we're still in the diagnosis phase of it. If you think about the turn of the century and industrialization, we had, I don't know, 30 years of child labor, unlimited work hours, terrible working conditions, and it took a lot of journalists muckraking, and advocacy to diagnose a problem. And I have some understanding of what it was. And then the activism to get laws changed. I feel like we're in a second industrialization of data information. I see my role as trying to make as clear as possible what the downsides are and diagnosing them really accurately so that they can be solvable. That's hard work, and lots more people need to be doing it. It's reassuring that Angwin thinks we are largely still in the diagnosis phase. If your understanding of these problems feels incomplete, that it is normal and natural. Nobody has a cure yet, although it is vital that we continue working to better understand and address the problems we are facing. One of the reviewers for this book, Fred Monroe, used to work in hedge fund trading. He told us, after reading this chapter, that many of the issues discussed here, distribution of data being dramatically different from what a model was trained on, the impact of feedback loops and on a model once deployed at scale, and so forth, were also key issues for building profitable trading models. The kinds of things you need to do to consider societal consequences are going to have a lot of overlap with things you need to do to consider organizational, market, and customer consequences. So thinking carefully about ethics can also help you think carefully about how to make your data product successful more generally. Okay, so questionnaires, let's skip that because that can be controversial, very opinionated. Even though it's just answering stuff from the book, I just don't want to get into that. And then there we go. So deep learning in practice, that's a wrap. Okay, so congratulations. You've made it to the end of the first section of the book. In this section, we try to show you what deep learning can do and how you can use it to create real applications and products. At this point, you will get a lot more out of the book if you spend some time trying out what you've learned. Perhaps you have already been doing this as you go along, in which case, great. If not, no problem either, and now it's a great time to start experimenting yourself. If you haven't been to the book's website, yet, head over there now. It's really important that you get yourself set up to run the notebooks. Becoming an effective deep learning practitioner is all about practice, so you need to be training models. So please go get the notebooks running now if you haven't already, and have a look on the website for any important updates or notices. Deep learning changes fast, and we can't change the words that are printed in this book, so the website is where you need to look to ensure you have the most up-to-date information. Okay. Make sure that you have completed the following steps. Connect one of the GPU Jupyter servers recommended on this book's website. That's no problem itself. We have it on our laptop. Run the first notebook yourself. Okay, we've done that. Upload an image that you find in the first notebook. Then try a few images of different kinds to see what happens. We did that with the Pokemon one. Run the second notebook, collecting your own data set based on image search queries that you come up with. Pokemon one again. Think about how you can use deep learning to help you with your own projects, including what kinds of data you could use, what kinds of problems may come up, and how you might be able to mitigate these issues in practice. In the next section of the book, you will learn about how and why deep learning works instead of just seeing how you can use it in practice, understanding that how and why is important for both practitioners and researchers, because in this fairly new field, nearly every project requires some level of customization and debugging. The better you understand the foundations of deep learning, the better your models will be. These foundations are less important for executives, product managers, and so forth, although still useful, so feel free to keep reading. But they are critical for anybody who is training and deploying models themselves. Yes. Okay, Understanding Fast AI's Applications, Part 2. And we will stop. And how exciting, we're going to be training a digit classifier next.